Hi 8th grade, this is Ms. B here with lesson 4.14. Today we're continuing to solve systems of equations algebraically using elimination. So let's take a look at an example that we've used elimination with before. So we have one of the first things that we're looking for when we're solving equations using elimination is that x and y are on one side of the equal sign. We call that standard form. So we would have x plus 2y equals 17, so this one is in standard form. Negative x minus 2y equals negative 26. This equation is also in standard form. When we're using elimination, we're checking to see that one of our variables will cancel out when we add the two equations together. So the coefficients on one of the variable must be additive inverses. So we're looking for the same number with the opposite sign. And we see that we have that with positive 2 and negative 2. So now if I go on ahead and add these two equations, 1x minus 4x gives me negative 3x, 2y and negative 2y will cancel out. When I add 17 and negative 26, I get negative 9. So now that the y's have canceled out, we can solve for the value of x. If we divide by negative 3 on both sides of our equation, we find that x is equal to a positive 3. But remember, in a system, we need a coordinate. We need an x and a y. So we're going to take this value of x and substitute it into either the first equation or the second equation. The first one looks like it'll have fewer steps, so let's go on ahead and substitute 3 into the first equation. So we're replacing x with 3 plus 2y equals 17. So our goal now is to get this variable y by itself. So we're going to subtract 3 on both sides, and we're left with 2y equals 17 minus 3 is 14. If we divide by 2 on both sides, we find that y is equal to positive 7. Remember to write your coordinate, 3, 7, since that will be the point of intersection. Let's look at another example where the equations are set up in standard form, but we do not have coefficients that are additive inverses. So take a look at this example and the one we just did together and identify the difference or similarities that you see in both examples. If you notice, the signs in the second equation have changed. So if I were to just try to add them straight up and down, none of the variables would end up canceling out. So in this case, it's our job to change one of the equations to create an additive inverse. So it would be nice if either the first 2 was negative or the second 2 was negative, and we're allowed to do that as long as we multiply every single term in the equation by the same number. So in order to turn, let's take the first equation, into a negative 2, we would have to multiply every value by negative 1. So we're going to distribute the negative 1 to each term on the inside of the equation. And what we're left with is negative 1x minus 2y equals 17. Negative 17. And the second equation remains the same. So now if I add the two equations, because I have a negative 2 and a positive 2y, those two variables will cancel out. So we're left with 3x, that's going to cancel out. Negative 17 plus 26 will give us a positive 9. If we divide 3 on both sides, we find that x is equal to positive 3. So if you notice, these two equations are actually exactly the same from the previous one in which we did the elimination review. So if I substitute x to be 3, we'll get the same value of y. I'm going to subtract 3 on both sides, and we have 2y equals 14. which means if I divide 2 on both sides, I get y equals 7. And our ordered pair is at 3, 7, which is the point of intersection. So if you had decided to change the second equation, let me use a different color. If you had decided to change the second equation and multiplied everything here by -1, you would get back this example, the one that we worked on together. So your job when you're using elimination is to make sure that one of your variables is going to cancel out. So you have one that's positive and one that's negative. Let's take a look at one more example that's really different. So in these examples that we've looked at so far, we've had at least the same number if it didn't have a different sign. If you look at the coefficient for x, we have a +1 and a -4. If we look at the coefficient for y, one of them is a +7, the other is a -14. So because neither of these variables are going to cancel out if we add them, your job is to change one of the variables in order for it to cancel out. So if I wanted to cancel out the x's, one of these would have to be a +4x, while the other is a -4x. So if I wanted to cancel out the x's, I could multiply every single term in the first equation by a +4. If I multiplied everything by +4, I would end up with 4x plus 28 equals 56. And then my second equation is still -4x minus 14, forgot the y there, minus 14y equals 28. So if I were to add the two equations now, the x values will cancel out and we must solve for the y. If you had decided to cancel out the y's first, let's take a look at what we would need to multiply each equation by. So again, we have +1x plus 7y equals -14. So if I wanted to cancel out the y's, I would have to have either +7y and -7y, or 14y, +14y and -14y. It's easier to go from a smaller number to a bigger since we would just have to multiply by a whole number. So let's change the first equation to have a coefficient of +14. So if I want to change the y value to be 14, I would have to multiply the 7 by 2, which means every single term in that equation must be multiplied by the same number. So we have 2x plus 14y equals -28. The second equation remains the same, -4x minus 14y equals +28. So now if I go on ahead and add these two equations, the y values will cancel out. So we're left with -2x equals -28 plus 28 gives us 0. If we divide by -2 on both sides, we find that x is equal to 0. So now we're going to substitute that into either one of the equations to solve for y. So I'm going to substitute it into the original equation, the first one, since I have fewer steps. So x plus 7y equals -14. Since x is 0, we're going to replace x with 0. And if we divide by 7 on both sides, we find that y is equal to -2. So our ordered pair, the solution to the system, is at 0, -2. Be sure to reference these 6 steps, which are on the top of your classwork handout, to help you with your problems today.